Hello and greetings, Hoseans. I am Sir Saul Apacible, your grade 8 mathematics teacher, extending a helping hand in understanding triangle inequality theorems. This video discussion will focus on theorems about triangle inequality. Firstly, we will illustrate triangle inequality, Hinge Theorem, and Converse of the Hinge Theorem. Secondly, apply the theorems on triangle inequalities. Let's get started. It is defined that a polygon with three sides is a triangle. The concept of a triangle is easy to understand, and you have probably learned it at an early age. Of course, as you grow older and study more in school, you learn additional concepts related to triangles, its different kinds, the sum measure of its interior angles, congruent triangles, and other related concepts of triangles. Review time! To jog those memories, let's have a drawing challenge regarding triangles. A scalene triangle is a triangle with sides of different measurements. On a piece of paper, draw a scalene triangle wherein the measure of the longest side is greater than the sum of the measures of the two shorter sides. Were you able to draw the triangle properly? If your answer is no, did you have a triangle that looked like this? Or this one? Perhaps this? From this activity, we can conclude that the length of the longest side of a triangle cannot be greater than the sum of the lengths of the two other sides. This is supported by the triangle inequality theorem. We now discuss this theorem at length. The triangle inequality theorem states that in a triangle, the sum of the lengths of any two sides is greater than the length of the third side. Which means that, given triangle ABC, the sum of sides AB and BC should be greater than the length of side AC. It also follows that the lengths of sides AC and CB is greater than side AB, and the lengths of side AC and AB is greater than side BC. Example time! Can a triangle be constructed with a side of lengths 3 centimeters, 7 centimeters, and 8 centimeters? For our solution, we take the sum of any of the two lengths. Let's take 3 plus 7 must be greater than 8. That's true. 7 plus 8 must be greater than 3. Also true. Lastly, 3 plus 8 is greater than 7. Definitely true. This solution follows the triangle inequality theorem. The sum of any two lengths is greater than the third length. Therefore, a triangle can be constructed. Good job in following that solution. Application time! In triangle BOS, side BO is equal to 8. Side OS is equal to 10. And side BS is equal to x. What is the range of possible values for side BS? To solve this problem, let's apply the concept of triangle inequality theorem. Since no third side is greater than the sum of the remaining sides, we can get the range by substituting to the equations provided in the definition of triangle inequality theorem to write three inequalities that express the relationships among the sides in terms of x. We have 8 plus 10 is greater than x, which makes x lesser than 18. We have x plus 8 is greater than 10, which makes x greater than 2. We have x plus 10 is greater than 8, which makes x greater than negative 2. Taking the intersection of these three inequalities, x must be greater than 2 but less than 18. Or in mathematical terms, x is greater than 2 but less than 18. Since side BS is equal to x, then side BS is greater than 2 but less than 18. With those applications, I hope you understood the triangle inequality theorem and how it can be applied to mathematical problems. Let us now discuss the Hinge Theorem. The Hinge Theorem states that if two sides of one triangle is congruent to two sides of another triangle, but the included angle of the first triangle is larger than the included angle of the second, then the third side of the first triangle is longer than the third side of the second triangle. Let's explore this theorem using this example. Given triangle ABC and triangle DEF, if side AB is congruent to side DE, side BC is congruent to side EF, and the measurement of angle B is greater than the measurement of angle E, then side AC is greater than side DF. Application time. Given the lengths of the sides of triangle ABC, which are side AB is equal to 15, side BC is equal to 8, and side AC is equal to 12, identify the largest and smallest angles in the triangle. To solve this problem, let's apply the Hinge Theorem. We deduce that the longest side is opposite the largest angle, and the shortest side is opposite the smallest angle. Therefore, angle C is the largest angle, and angle A is the smallest angle. Application time. Given the figure, describe how side MR and side MP are related. To solve this problem, compare triangle RMB and triangle TMB. By reflexive property, side MB is congruent to side MB. Also, side BR is congruent to side BT as given in the diagram. Angle RBM and angle TBM form a linear pair, so they are supplementary. Thus, the measurement of angle RBM plus the measurement of angle MBT is equal to 180. But the measurement of angle RBM is equal to 110. So, 110 plus the measurement of angle TBM is equal to 180. Or the measurement of angle TBM is equal to 70. Therefore, the measurement of angle RBM is greater than the measurement of angle TBM. Hence, by the Hinge Theorem, side MR is greater than side MT. Very good in keeping up with this example. Transitioning to the converse of the Hinge Theorem will be much simpler since you already understand the Hinge Theorem. The converse of the Hinge Theorem states that if two sides of one triangle are congruent to the other two sides of another triangle respectively, and the third side of the first triangle is longer than the third side of the second, then the angle opposite the longer side is larger than the angle opposite the third side of the second triangle. Let's explore this theorem using this example. Given triangle ABC and triangle DEF, if side CA is congruent to side FD, side AB is congruent to side DE, and side CB is greater than side FE, then the measurement of angle A is greater than the measurement of angle D. Application time. Given the figure, describe how measurements of an angle EMR and measurement of angle RMB are related. To solve this problem, in triangle EMR and triangle RMB, side MR is the common side. Hence, by reflexive property, side MR is congruent to side MR. Side EM is equal to 3.1 and side BM is equal to 3.1. So, side EM is congruent to side BM. Side BR is equal to 4.6 divided by 2 or 2.3. And side ER is equal to 2.8. Then, by the converse of the Hinge theorem, the measurement of the angle EMR is greater than the measurement of angle RMB. Now that we have applied these three theorems together, I'll give you a chance to do it on your own and let's check your understanding together. You are going to identify if the given side lengths can form a triangle. You are given 5 seconds in the video, and if more than 5 seconds is needed, please pause the video as I'll be sharing the answer right after 5 seconds. Number 1. Given side lengths of 4, 5, and 10, can a triangle be formed? If your answer is no, you are correct because 4 plus 5 is 9, not greater than the remaining side, which is 10. Number 2. Given side lengths of 4, 6, and 10, can a triangle be formed? If your answer is no, you are right because 4 plus 6 is 10, not greater than the remaining side, which is 10. Number 3. Given side lengths of 3, 7, and 9, can a triangle be formed? If your answer is yes, you have done well because 3 plus 7 is 10, greater than the remaining side, which is 9. This time, you are given the side lengths of a triangle. Identify which is the largest angle. Number 1. Side DE is equal to 5. Side EF is equal to 8. And side DF is equal to 12. What is the largest angle in triangle DEF? If your answer is angle E, that is correct because angle E is opposite side DF. Number 2. Side JK is equal to 4.9. Side KL is equal to 4.5. And side JL is equal to 5.2. What is the largest angle in triangle JKL? If your answer is angle K, that's brilliant because angle K is opposite side JL. Did you get all the items right? If yes, great job! To summarize, the triangle inequality theorem. In a triangle, the sum of the lengths of any two sides is greater than the length of the third side. Hinge theorem. if two sides of one triangle is congruent to two sides of another triangle, but the included angle of the first triangle is larger than the included angle of the second, then the third side of the first triangle is longer than the third side of the second triangle. The converse of the Hinge Theorem. If two sides of one triangle are congruent to the other two sides of another triangle respectively, and the third side of the first triangle is longer than the third side of the second, then the angle opposite the longer side is larger than the angle opposite the third side of the second triangle. That ends our discussion on triangle inequality. Excellent work, class! Once again, this is Sir Saul Apacible saying, with your mind, body, and soul, everything is possible. See ya!